get started, we need to understand the method of marker pasting that software can quickly identify for alignment. In order for the markers to be read, it must be ensured that 4 or more are present in a single frame at the same time. The scanner won't be able to detect the markers when the pasting of the markers does not adhere to the above requirements. The scanning area that the scanner can capture will expand in direct proportion to the number of markers. Tip: the paste distance between markers is slightly different for each device. For your convenience, the following is a list of relevant details regarding the pasting distance of the markers suitable for specific scanner models. Some objects with special structures, such as tubes, can only meet the spacing requirements between two markers, and the object cannot be thoroughly scanned due to the particularity of its structure. Therefore, it is also essential to have a specific marker density. We can use the following approaches to scan such objects: apply a large number of markers, generally at least 5 or more, to the side of the tubular object. Place the tube on the table and apply the markers evenly and randomly around the object if the object's size makes it impossible to paste markers on it. The density of the paste will vary depending on the situation at hand. Start scanning after pasting the markers. Confirm that you have recognized every marker on the tube. Turn the tubular item over after creating a new project in the software's Left Project Group section. At this point, be careful not to touch or move the markers placed on the object. Instead, paste the original repaste onto the desktop's marked areas in a way that is both uniform and random from the previous one. The number of markers can be adjusted to suit a particular need. Press the play button again to begin scanning. Similarly, it is essential to scan every marker on the tubular object, as at a later stage, the two sets of scanning data must be aligned through the common markers on the object. After clicking Generate Point Cloud, we can manually align the two sets of data. You may see the aligning preview window at the bottom of the software. Click to choose two sets of data in the fixed window and the floated window, respectively, then select Markers Point Align and click Apply. The public markers, or some of the markers attached to the object, have been used to align the two sets of data. If there is nothing amiss with the overall data after aligning, the alignment was successful. For some smaller objects or objects with even more complex structures, it is impossible to directly paste markers on the object itself for scanning, and even if the paste conditions can be met, it will affect the complete acquisition of object. For the above scenarios, we can scan in the following methods. Place the object on the table, scatter markers around it, then scan it with multiple projects utilizing the attached markers. Start scanning after you've finished pasting. After the scan is finished, select Generate Point Cloud, remove any irrelevant data, and create a new project under the project group. To prevent the repetition of the first time, flip the object over while simultaneously adjusting the location of the marked point. Continue scanning. Similar to how you can generate point clouds and process data after scanning is complete, you can also repeat the process of starting a new project, flipping the object, and adjusting the marker pasting position if the data acquisition is still insufficient and there are dead spots in some areas of the object. Multiple sets of data can be combined by manual alignment after the scan has basically completed. Two sets of data in the fixed window and the floated window can each be selected by clicking. We can select feature alignment because the object's features are easier to identify. We have the option to manually identify common points within the data to perform the alignment if it is not aligned correctly. The software will then automatically fit. The alignment is successful if the data produced is not subpar. Due to their extremely thin thickness, some objects with faint features or thin walls cannot have markers attached to the side. Additionally, using the markers will not allow for the scanning of the edge transition. We can scan with the following scenarios. Prepare additional, single or multiple, objects and use them as auxiliary references by marking them with markers. And then apply the markers in the appropriate locations on both sides of the thin-walled part. Take note that the paths of the markers applied to the two sides must differ. The thin-walled portion should next be stabilized on its side, and the prepared auxiliary reference items should be placed on both sides, being cautious not to stick to the object. Start scanning. In order to scan the transition between the two sides of the thin-walled section, it is necessary to scan the auxiliary reference objects on both sides simultaneously through the markers on the reference objects. We simply need to retain the thin-walled sections of data we require after simple data processing. Create a new project in the project group after generating point clouds, then place the thin-walled component horizontally on an object with one side facing up. It should be noted that the thin-walled parts must be suspended in the air as much as possible while scanning as little as possible on the supporting objects. Beginning the scanning, we may utilize the zoom in/out function to enlarge the local region to gain a clearer picture if the object itself has more details. Similar to this, only the thin-walled section of the data needs to be kept when processing data and generating point clouds. In order to get more complete data on the thin-walled part, we can create a new project. In essence, we will basically repeat the second scanning and processing by turning the object to its other side and setting it on the supporting object. We choose to apply the manual alignment method after all three scans are completed. The software can recognize the public markers on the object itself for alignment through markers point aligning. It is feasible to prevent misalignment due to the distinct characteristics of the markers that are pasted on opposite sides of the thin-walled part. Verify the data alignment once the fitting is done sequentially. There is no need to pay attention to the floating makers because they are from the previous auxiliary reference. The three projects' data fitting is flawless, and the scanning was successful. When scanning some special objects, we have the option of scanning the markers that have been applied to or around the object before the actual point cloud scanning. By using this technique, the probability of misalignment can be effectively decreased, and the accuracy of scanned data is improved. Take HX's software as an example. First, we perform a global scan for the markers attached to the object's surface by choosing the mode of scanning markers from the left menu. The scanning interface now just shows the view of the markers. After scanning, optimize the marker data. Now that the marker data has been developed, you can save it as a separate P3 format file, which makes it easy to import later. We can import the previously scanned global marker file when we open it for the second time, and we can then begin scanning the point cloud. Typically, the bottom cannot be directly scanned even while the object is on a turntable, but with the help of global markers, we may flip the object and scan the data at the bottom without starting a new project. After completing the front and side scans, we can remove irrelevant data or apply a variety of editing tools to enhance processing efficiency. Then, without having to start a new project, turn the object over so the underside is exposed, and begin scanning. If there are still some hidden corners that have not been scanned, we can move the object into a new position so that the bottom is facing up and scan more corners to get a more thorough data collection effect. After importing the global markers, if there are still alignment issues, you may choose to add markers. By selecting this option, the newly identified markers will be added automatically as a fitting reference when scanning data later.